Hey guys, welcome to the first chemistry video, and let's get straight into it. So right here we're looking at the periodic table of elements, which is composed of the elements that have been discovered so far. And the creator of the periodic table of elements is Mendeleev, who was a Russian scientist, and he found out that when elements were categorized by increasing atomic number, and the atomic number is this number. When they're categorized by increasing atomic number, when they are sorted into groups, and groups are just columns, you see a trend in their properties. So I know I said a lot, so now let's dissect this. So first let's talk about the atomic number. The atomic number is just an easy way to categorize and sort elements, and the atomic number is also representative of the amount of protons in an element or atom. So now let's talk about what protons actually are. So usually when talking about atoms, let's draw this atom right here. Let's name it A. There are called subatomic particles. So we have three common subatomic particles. We'll get to more later, but the most common and proven ones are protons, P, neutrons, and electrons. So protons have a positive charge, neutrons have a neutral charge, and neutral charges are zero charges, and electrons have a negative charge. So apart from the charge, we also have the mass, because in science, basically, almost everything has mass, and so do protons, neutrons, and electrons. No matter how small they are, and they're really small, they're in atoms, and atoms itself are really small. Therefore, these have to be exponentially smaller. So the mass of a proton is approximately 1. And you might be saying 1 what? And they're 1 AMU, which stands for atomic mass unit. It's just an abbreviation. And it's also the same for neutrons. We have a atomic mass of 1 AMU. But when we get to electrons are very small. Therefore, they have a very minute atomic mass, which is very close to 0. Now, this curly sign just means close to. So when we do a straight equal sign, that means exact, but when we do curly equal sign, just means close to. So the reason why I put close to 1 and close to 1 is because it's not technically exactly 1, but it's very close to 1. And same thing for the electron mass. It's not close. Obviously, it can't be 0, but it's very close to 0. And when we think of an atom, we think of the standard diagram of this. Let me just draw this out. So this is a poor diagram of an atom, but as you can see, we have the nucleus, which houses the protons and neutrons. And these rings out here are basically the path of the electrons. Now notice how I'm not saying the electrons, and that's because electrons travel very fast and they orbit around the nucleus. So we have a nucleus over here, and let me clear up some space. So we have the nucleus over here, and we have electrons orbiting this nucleus. And within the nucleus, we have P's and N's. And for the most part, the amount of protons is equal to the amount of neutrons. So, and P, just for reference, P is equal to protons and N is equal to neutrons. So number of protons equals number of neutrons. And oftentimes this is also the same for electrons. So essentially they're the same amount of electrons, protons, and neutrons in each element. But obviously there has to be an exception, and you will see an exception later on. But just for the basis of it, let's just talk about scenarios where where protons, neutrons, and the number of protons, neutrons, and electrons are all equal. And just to clear any misconception, this is always not going to happen. Most times, well, actually, yeah, more than half the time, protons and electrons will have the same amount of protons and electrons, but the neutrons will oftentimes be higher than the protons and electrons, and we'll talk about why that is later. So inside of a nucleus, we have protons, which have positive charge, and neutrons, which have zero charge. So basically, these protons or neutrons are just sitting inside the nucleus, whereas the electrons are outside. And these electrons are orbiting this nucleus, so they're constantly moving. And I like to draw this ring to show where they are, because no one can directly tell. Well, there is a reason for that. There's a reason of why we can't determine the exact velocity and mass of an electron, and that's relating to the law of uncertainty. But let's just think of it of we can never really find the true place of an electron, because it's always orbiting and it's always moving. And most times you actually can find it. Forgive me. Most times you actually can find the place of an electron, but it's very hard to. And once you do, you actually set the electron off path. And I need to stop